Hello. So my name is Dave Phelps, and I am a cloud solution architect at Microsoft based out of the UK. And I'm going to be talking to you about understanding APIs with Azure Application Insights. So I'll talk about a little bit about Application Insights, an overview, what Application Insights is, how to configure Azure API management for Application Insights, then jump into a demo of App Insights, look at dashboards, workbooks, availability testing, and finally, alerting. So most of this presentation is actually demos. So what is Application Insights? Well, it's a way of being able to track and log how your application is running. And we can track application data, we can track business data, for example, an order ID, so that we could make the job easier for support to understand what's happened to an order at a retail company, for example. Application Insights also has built-in support for end-to-end correlation. So what this means is that when a request is sent from a website, for example, or a browser, that request would be sent to an API. The API might then call some kind of back end. It could be an Azure function, logic app, or something different. Maybe that drops onto a queue, which is picked up by another process. And in the world of microservices, it can be quite tricky sometimes to understand what that journey looks like from a runtime perspective. Application Insights makes it very straightforward to understand what your application looks like at runtime. We also have availability tests, so we can run some tests to verify that your APIs are actually functioning, and we'll drill into that in a demo later. And finally, we can look at exceptions and performance, so understanding why my application may have failed and where it failed. So let's jump into some demos. So the very first demo that I'm going to show you is application map. An application map is that runtime aspect that I was just talking about. And here is application map, and you can see that there are a whole bunch of different components here. I'm just going to zoom in so that you can see what's actually going on here. It's a bit tricky on this screen. It doesn't actually matter too much, but you can see here I've got my API management instance, which is shown here, and I've got two clients that are calling my API or calling an API on API management. So I've got my availability test that we'll look at later, and I've also got another client. So if you have multiple clients calling your API, that will get reflected in application map. We can then see that my API management instance is calling into this is actually a logic app. The logic app is then talking to a SQL database. It's dropping a message onto a queue. That is then being picked up by a function app. The function app is then dropping onto another queue and hitting these other two function apps here. So if I just zoom out for a second, just so you can see the end-to-end flow, this is particularly useful in understanding what my application actually looks like at runtime. But I can actually do some other things here. So I can see that there's a little red here, which shows that I've had some failures. And this is on the API call in API management. So if I click on this, we can see up here that we've got some failures. So I can click on investigate failures. And then it comes here and it's showing me a graphical representation of, for the different requests, how many failures I've had. You can see I've got some 502s here, so I could click on that. And App Insight is automatically suggesting an end-to-end of a particular trace that's failed. So if I click on this, then we get this end-to-end view. It's a bit, if I do that, then we can see that we've got the availability test, which made the call into API management, which made a backend call, which called into my Logic app. And finally, down here, we can see that I'm executing a SQL, using a SQL action in Logic apps. And then we've got this red item here. And if I click on this, you can see the exception details, and it's saying could not find store procedure, create customer 2. And I manufactured this earlier on to force it to fail. And I can click on show more, and we can actually get the entire stack trace. So you can see this is particularly useful with your applications in production, where if you see a failure, you can drill right into the detail, right down to the exception that caused the failure in the first place. So if we go back to application map, we've also got this failures tab here, which does a similar thing where I can drill into those details that you just saw from application map. We've got performance as well, so we can then see how our APIs and also all of the backends are performing. So here's my API. I can click on that. I can then drill into the details, so I can see the call times of my API, but also, more importantly, not just the API itself, but all of the dependencies. So I can really get a feel for how my API is performing, because of course, it's not just about the API. The services on the back end of that API are obviously really important, because they're the things that are adding up the different call times that goes back to the client, and if it's an HTTP call. So I've shown you what application insights looks like at a high level. How do I configure that inside API management? And I just need to pause here for a second. I'm not quite sure what went wrong there. So I'm going to have. So here I am inside API management, and this is where I can configure application insights. So I can click add, and it's going to give me a list of the different application insights instances that I have configured in my subscription. And you'll notice here we have this add availability monitor tick box. If I tick this, then API management is going to configure application insights to go and hit my API management service to validate that it's actually up and running. And we'll see that in a second. But once you've added an application insights instance into APIM, we can then go to individual APIs. For example, my Contoso orders API here. And we can click on settings, and we can then select the application insights instance that we want to use. And this is particularly useful because if your API management service is being shared amongst multiple teams, then each team may want to have a different application insights instance, so they can have control of it. And it may be that the data that is being recorded there should only be seen by certain people, controlled through role-based access control. So once I've configured my application insights, I can then go and configure some other settings. So I mentioned about the correlation earlier on. This is what helps API management send a correlation token to the back-end service, which is what adds to that application map that you saw earlier on. I can log the payload. So we need to be careful doing this because depending on the payload size, this could have an impact on performance. But nevertheless, if we log the payload, then that becomes useful from a query perspective, being able to pull out certain pieces of data like the order ID that I mentioned earlier on. But of course, it's not just about API management. The back end, that could be, for example, a function app. The function app could also be tracking some custom data that might be useful to us. So that's how we configure application insights in API management. And we've seen the basic overview of application insights with the application map, exceptions, performance, etc. But we can also navigate into the logs. And so I've got a very simple query here that if I run this, is going to show me how many failures I've had and how many successes I've had, because application insights is writing this telemetry into a bunch of different tables that you can see on the left here. So there's a request table, we have exceptions and dependencies, which allow us to query those tables and create some custom queries. So at its most basic level, if I just run a query here, then these are the items that come back. And we can see my API management call here, the logic app actions. I can drill down into a effect. If I just go back 1 second and I go and pick an operation ID here. Operation ID being the one value that will correlate across all of the different API calls. So in my case, I've got my availability check. This is my client, goes to APIM, which goes to a logic app. The logic app executes a bunch of actions, which then goes to the 3 function apps I spoke about. So we could also query on some business data. So in my case, I'm logging the request body, but I could, using logic apps or functions, I could just write out the product name, which would be more efficient. But just for demo purposes, I'm showing how I can pull out the product, and then we can see how many orders have been received for each different type of product. Now, I mentioned that this particular process involves a bunch of function apps. It involves a logic app. It involves API management. So what we can do is create another query that allows me to pull out the product name, an order ID, the name of the person that placed the order received, and crucially, when it completed, because this completed time is actually the time when the final function app executed successfully. So what I'm doing here is actually showing the time that the order hit API management right through to the time that the order completed in my backend process. So I could also do something like this, where I can query and understand who is making calls to my API. Now, these email addresses are the email addresses of API users. So they could be people who own an app or a website, for example. And all I'm doing here is pulling back the email address. And I could use this for cross-charging, or I could use it for billing purposes. And if I just show you very quickly, this is my API management instance, and this is my API. And I'm using a trace policy to just write out the details of the user that has made the call to the API. And by that, I mean the person who owns the API key, the person who has built an app or website. And so what API management does at runtime is it does a lookup on the API key to pick up the context of that API call. And I'm just pulling out email address, first name, last name, so I can then go and use that in my queries. So once I've written a query, I can then save this to a dashboard, so that that dashboard could then be saved and it could be shared with other people. And I can do that by just clicking Pin to Azure Dashboard. And I've already pinned a few of these. And if I go to my API Day dashboard, then I can turn auto refresh to on. So here are this is the number of calls that people are making. I have my products, and over here I have my analytics. So this would be particularly useful to give to someone in support, for example, so that they can see what's going on. Maybe someone in the business might be quite interested in some of this information. So that's fine, and we can create these visuals, but wouldn't it be even better if we could create visuals that were a lot more targeted to the people that want to monitor the APIs? And this is where workbooks come in. So I've created a workbook here that allows me to search on an order ID. And the default view I get here, if you recall, this, the information we have in App Insights is actually quite technical, but I've pulled out a bunch of information like when the order was received, when it was completed, the customer name, the order ID. So if a customer were to phone up and say, hey, I haven't received my order and my order ID number is this, then I can just do a search and I can find my order. I can click on that order and it's actually off the bottom here, but you can then see that we can drill down. So I can then do a drill down into a specific order and I can see that the order was received. I can see all of the actions that took place. And then what I can do is if there is a failure, I could drill down into that even further in order to understand any kind of exceptions that I may have had. And if I just click edit on this workbook, you can see that I've just added these visuals. I've added an order ID field. I've got this query here where all I've done is just written a query that is pulling back the information that I'd like. And these are incredibly flexible, and I think they're particularly useful for support departments so that you can search on keys or data items that are actually really relevant. And it means that people don't need to go and learn these custo queries that are in the logs. They can just have access to a workbook and get the information important to them. The final two things I wanted to show, firstly, is availability. So way back a few minutes ago, when I showed configuring one of the application insights instances, I ticked the box about availability. And you can see here that we have my APIM instance, and I've got a very successful set of calls here. This is just checking that API management is up and running. But what I've also done is I've created a custom availability test, because my API could actually be on a private network, or it could be protected with OAuth, like mine is. I'm doing a validate JWT here. And the default tests that you can create here through the portal, they don't give you that flexibility. You can't be on a private network or using kind of more complex security protocols like OAuth. But using the App Insights SDK, which is pretty straightforward to use, and I'll share details on how to do this, we can create our own custom test. And I did this just with an Azure function on a timer that's hitting my API, and it's actually fetching a token in order to pass that validation test that we saw. So we can see that I've got some successes, I've got some failures. And if I just click on my failures, I can do the same thing I did before. And then I get my end-to-end trace, and I should be able to navigate down to, there it is. And it's actually the same error, my contrived create to store procedure. So what's cool about this is that you can actually have availability tests that are actually testing the API itself by fetching a token. It can be on a private network. And if there's a failure, then we can just drill straight down into the individual error to understand what's going on. So that's availability testing. And the very final thing I want to show are alerts. So I've created an alert here. We click on alert rules, which is called alert if not complete in 5 minutes. So I will just click on edit, click on condition, and I've written a query here that is actually calculating the amount of time that it took for the order to be completed. So if, for example, my order didn't complete for some reason, then what I'd like to do is to generate an alert for somebody to be able to be notified that this hasn't actually completed. And my check here is for if the time taken is more than 300 seconds or 5 minutes. So you can see that it's actually incredibly easy to be able to create an alert that is going to notify somebody in the business, for example, that there's a problem, or it could be somebody in support, so that they can then take action to understand what's going on. But of course, the alerts don't have to be just about how long it took to complete. It could be that we're alerting on some of the business data, or possibly the number of failures that we've had over a particular time period. And so once I've created my alert, I can then configure who an email goes to, or it could even be a webhook, or I could trigger some other process to take some kind of action. And I think that is the end of my presentation. Thank you very much.